Hello, this is Lu Fan from Edinburgh Napier University. Today I'm going to give you a brief overview of the sa.FIRE technology. The big idea of sa.FIRE is to protect sensitive resource within an organization using a security authority, namely the single point of contact, in short, the SPOC. A SPOC is essentially a security authority that provides claim-based identity management and access control. To make the SPOC fully functional, a system admin needs to define the resource types processed by the organization and the actors who may actively request and consume such resource. This can be done using the SPOC's management software called the sa.FIRE Studio. This slide shows a screenshot of the sa.FIRE Studio. Its application interface consists of the following parts. Firstly, a window for defining a domain's organizational structure, such as departments, groups, and roles. In the screenshot, we have defined the root organization as Edinburgh Napier University, under which there is a School of Computing that further contains a research group called CDCS. Within this group, we can continue to define hierarchical roles, like staff and student. Staff comprises of professors, lecturers, researchers, and so on. Basically, these terms are altogether referred to as the organization's domain ontology. The definition of domain ontology can be extremely flexible, and it should be modeled according to an organization's real setup. Secondly, there is another window for defining resource types. These can be software systems, subsystems, services, or information attributes processed by the organization. For example, in the screenshot, Edinburgh Napier University has a software system called Tracker, which is used to maintain a number of forms. Among them, there is a module attendance form. These useful terms are also part of the organization's domain ontology. Now, using these two windows, we have produced a set of well-defined vocabulary, which we can use to describe fairly complex access rights later on. Next, on the right, there are three boxes for the system admin to enroll users, services, and data buckets. Using the user's control, the admin is able to create any numbers of user accounts and associate the users with different roles that have been defined previously. Furthermore, the admin has two options, whether to create a user account within the SPOC's Active Directory or just in a simple user database. If the account was created in Active Directory, the SPOC would be able to authenticate the user by itself. Otherwise, the SPOC would rely on an external identity provider to authenticate the user. The main purpose of the services control is to define a service's dependencies. That refers to the information attributes that a service relies on to fulfill its functionality. The SPOC would keep this in mind, and when the user subscribes to a particular service, the SPOC would automatically assign access rights to the service, so it is able to retrieve necessary information about that user. The services retrieve information from the data buckets. This is sa.FIRE's data persistence layer. A data bucket service only releases data to a user or a service instance with a valid data ticket. A data ticket is a security token issued by the SPOC. So far, we have defined domain ontologies, services, and data buckets in the domain. The next step is to set up access rights around this triangle. Specifically, which users, roles, or groups are allowed to consume which services, which users, roles, or groups are allowed to see what data, and which services are allowed to find out what data about which users. All of these access rights can be defined using the policy editor. I will demonstrate how to use the policy editors very soon. When a security policy is created, it will show up in the form underneath. the policy is written in pseudonymous format to enforce contextual privacy. In other words, only authorized users can parse the policy into plain text. All right, I have explained the fundamental concepts around sa.FIRE technology. Now let's actually create some security policies using the sa.FIRE Studio. Before we start sa.FIRE Studio, I want to show you a small piece of software that is the request maker. I prepared this software to validate the effect of information sharing policies that we will create. Here, by clicking this button, you can see I have hard-coded an information request. This request is regarding Sophie123, that is our user account. And this request is asking for Sophie's e-Redbook record, that is the data attribute the information request is about. And the request is from a nurse, that is the requester's role. And the relationship between the information requester and the data owner is nurse star. That means the information requester is the personal nurse of Sophie's. In practice, such information should be provided by security claims from trustworthy identity providers and attribute providers. Here, just for demonstration purpose, I hard-code such information. If we submit the request now, you see an error message, invalid data, because the vocabularies we use here in the request, they are not well defined in the domain ontology. So the Spock cannot understand what you are talking about. Okay. Next, let's start the sa.FIRE Studio. This is the login page. To log on to the sa.FIRE Studio, you need to provide a valid username and a password. Here I have hard-coded a demo administrator. And in this job box, we have two Spocks. One is for Edinburgh Napier University, the other one is for SiteKit. And in this scenario, we choose SiteKit Spock. Submit. Okay, now we are in the Spock, we are in the sa.FIRE Studio interface. Just let me increase the size of the GUI so we can see every component in the screen. Okay, good. So we click on the load menu to load existing ontology definition from the Spock. Okay, so in the main ontology window, we see a number of groups and rows defined previously. And in the reference ontology tree window, we see some applications defined previously. So we have defined two applications. One is called e-Redbook, and under this application, we defined a very simple resource that is e-Redbook record. This is currently a monolithic resource, but according to the application scenario, we can break this down into a number of atomic information attributes. And we also defined e-Silverbook and e-Silverbook records. For the organizational structure, we defined a group called e-Redbook group. And under this group, we defined a role called subscriber. So this basically represents all the customers subscribes to e-Redbook. And we have created a formal care group. Under this group, we have created a subgroup called medical staff and another subgroup called medical relationship. So for medical staff, we created two medical roles, GP and nurse. For the medical relationship, we create two relationships, GP star and nurse star. Okay. The next step is to create an actual user account within the subscriber role. We right-click on subscriber role, and in the menu, we choose Add User. Now we see a window for the admin to enroll user accounts. If Enable Local Log On is enabled, is ticked, That means you want to create user accounts within the Spock's Active Directory. So the Spock is going to authenticate the user by itself. For demonstration purpose, we just leave this unchecked. That means we are going to use an external identity provider to authenticate the user and make a claim, so the Spock knows who is the current user. This box is required, so we need to type in the account name, and according to my design, that should be Sophie123. We can safely leave all the other boxes empty, and we specify the first name of user is Sophie, the last name, for example, Smith. Okay. And we click on Submit button. Now we can see one user is created under the subscriber role of eRedBook group. We can try to retrieve existing users in other groups. For example, we can get user details, and the user's control is empty because we didn't create any subscriber user under this group. And we try to retrieve the user we just created, and we see Sophie is there. You can, of course, edit Sophie's information at any moment. Okay, so now Sophie123 account is defined, and we can see the nurse role is defined, the nurse star relationship is defined, and the eRedBook record information attribute is also defined. Now we submit the request. The Spock should not complain about undefined ontology, and it should show green or red signal here. If the signal is green, that means according to the current security policies, this information request should be permitted. If it's red, that means according to the current information sharing policy, the request should be denied. We try to submit the request. And unfortunately, we see a red star, a red signal, because we haven't defined any positive information sharing policies to allow this request. Okay. Now we try to create one policy, that is to allow all the medical staff to request for Sophie's eRedBook record. And in the policy editor, in this drop-down box, we can choose the type of policy is a delegation policy. And the action we want to take is to permit. And the role we want to permit is medical staff. Let's copy the Q name, the qualified full name of this role, and paste here. And the permission we want to give is read and write. And the information attribute we're talking about is eRedBook record. So we copy its Q name and put it here. And eRedBook record about which information owner. The owner is Sophie, so we copy Sophie's name and put it here. And we should specify this information sharing policy is effective from what date to what date. So it's effective from today to sometime later. Okay. Now we can click on the Validate and Add Rule button. If everything is fine, this rule, this policy, should be accepted and installed with the Spock. Okay, policy created successfully. We don't see anything here in this form because we have to actually retrieve this policy. It was created under this group. So let's right-click on this group and get policy details. And we have one delegation policy created previously. And you can see that this policy is not understandable because it is pseudonymized. If we click on the Parse button, now we see what does this policy mean in plain text? Basically, it means we are permitting medical staff group to read and write e-Redbook record of SOPHIE 123 from this time to that time. Okay. Because previously we have defined both GPs and nurses, they are members of medical staff group. So now if we make the same request again, that should be permitted because we say the current requester is of nurse role and nurse is a member of the medical staff. So we submit this request, and as expected, it is allowed. So this person can safely see the e-Redbook record of SOPHIE 123. Okay. Now, just for demonstration purpose, let's create some other conflict policies. For example, let's choose the GP role, and we try to create another policy under this role. And that is also a delegation policy, but now, instead of permit, we try to deny the GPs to read and write e-Redbook record of SOPHIE 123. If we try to make this policy, you can see it is not allowed. There's a potential problem because this policy conflicts with an existing higher level policy, and that policy is we are permitting medical staff to read and write e-Redbook records of this particular patient from this time to that time. So there is an existing policy at a higher level, and we are creating a lower level policy that is against that existing policy, and the SPOC will not allow this to happen. So as you can see, the SPOC's policy engine is designed and implemented in the intelligent way that there's never a conflict or a redundancy or a shadowing that would ever happen. Conflict means if you have, in a hierarchical role relationship, you have conflicting policies to be created, it is denied. And redundancy means if you have created a policy for this particular group and you are trying to repeat this policy for a lower level role, and that later policy is identified to be redundant because everything is defined on the higher level. And overshadowing means if you firstly created a policy for a lower level role, for example, GPs and nurses, and later on you try to repeat the same policy on a higher level group, and this policy will overlap with existing lower level policies. That is possible, but the SPOC will warn you that you have already defined lower level policies. Okay, so now we have allowed all the medical staff to read and write SOPHIE's e-Redbook record. That is quite permissive. We want to narrow this down to allow only SOPHIE's own nurse, for example, or SOPHIE's own GP to see SOPHIE's record. So we try to delete this policy. Now it's gone. We can revoke any existing policy by click a button, and we try to submit this request again. It is denied because the policy is gone. The access right has been revoked. Now we create another policy to allow only SOPHIE's nurse to see SOPHIE's e-Redbook record. So we copy its queue name, and it is a delegation policy. It is permit, and we allow SOPHIE's own nurse to read and write the Redbook record from this time, that time. We add this policy, and everything's fine. We can retrieve the policy we have added by right-click on the nurse relationship and get policy details. And you can see this is the policy you just created, and it means we are allowing the nurse-star relationship to read and write e-Redbook record of SOPHIE 123. Okay. And now we try to send the request again, but now we just say, currently the information requester is a nurse. We're not sure whether the nurse is Sophie's nurse or not. It's just a nurse role in general. We submit the request and it is denied. So now we say this nurse is Sophie's personal nurse, and we try to submit this request and it is allowed. So you can see currently we are making access rights according to the user's identity or user's role and the information requester's role or information requester's relationship to the data owner, and you can specify any fine-grained data attribute name that you want to request for. Okay, and we can just try again. If that is just a nurse, so the potentially a trustworthy attribute provider can only verify the current information requester is a nurse, but it is not necessarily the particular nurse of Sophie's. And we submit the request. It is denied. Okay, that's pretty much I want to demonstrate today. If you have any further questions, please visit cloud4health.com and you can forward your question to our technical team. Thank you very much.